It was 11:47 p.m. when the power went out outside. The temperature had already dropped to -31. The wind was hitting the side of the house, so hard the walls were groaning. Inside, a man sat in the dark, listening to his furnace go silent, that terrible, final click of a system that no longer had power to run. He had a generator. He went to the garage, yanked the pull cord. Nothing. Yanked it again. Nothing. Again. Nothing. The electronic control module, the little computer chip sitting inside that brand new, well-reviewed, highly rated generator, had seized in the cold. It was reading error codes it couldn't process. It was waiting for a signal it would never get. It was, for all practical purposes, a 600-pound paperweight sitting on a concrete floor at -28 degrees. His pipes froze before sunrise, his water heater cracked by morning. He lost a chest freezer full of moose meat, salmon, and halibut. Roughly $2,000 of food his family had spent an entire summer harvesting. And the generator? It started just fine once he brought it inside and let it warm up for 4 hours. That story is not rare in Alaska. That story happens every single winter in dozens of communities. To people who did everything right, they prepared, they bought backup power, they thought they were protected. And they were left exposed because nobody told them the one thing that actually matters when you live this far north. Not wattage, not runtime, not brand reputation. The chip. This is the conversation nobody in the generator industry wants you to have. Because the generators with chips are the ones with the biggest marketing budgets, the prettiest packaging, and the most prominent placement at every big box store from Fairbanks to Juneau. They look impressive. They have digital displays. They have automatic start. They have remote monitoring via Bluetooth. They have everything, except the ability to start when you need them most. So today, we're going to fix that. We're going to break down exactly why electronic control modules destroy generator reliability in cold climates, what to look for in a generator that will actually save your life, and then name the only 3 machines that smart Alaskans, people who have actually survived brutal winters, people who have actually stood in a dark garage at -30, pulling a cord and praying, actually trust. Stay with me. This information is worth your time. Let's start with what a chip actually does inside a generator, because once you understand this, you will never buy the wrong machine again. Modern generators, especially anything manufactured in the last 10 to 15 years targeting the consumer and prosumer market, are built around electronic control modules. These ECMs manage ignition timing, fuel mixture, automatic choke adjustment, voltage regulation, and overload protection. They communicate with sensors throughout the engine. They make real-time decisions about how the engine should run based on temperature data, load data, and operational feedback. In moderate climates, this is genuinely useful. The engine runs more efficiently. Fuel consumption drops. The generator adjusts automatically to changing load demands. You get cleaner power output. On paper, it sounds like progress. In Alaska, it is a death sentence. Here is why. Electronic control modules have an operational temperature range. Most consumer-grade ECMs are designed to function reliably between -4 Fahrenheit and about 140 Fahrenheit. That sounds acceptable until you realize that -4 Fahrenheit is roughly -20 Celsius, and large portions of Alaska regularly hit -30, -40, and beyond. Interior Alaska communities like Fairbanks, Talk, and Delta Junction routinely see -50. The temperature range on that ECM is not a suggestion. It is a hard limit. Below that threshold, the microprocessors slow down. The sensors feed incorrect data. The module makes bad decisions or no decisions at all. But here is what makes it truly dangerous. The ECM failure is not always obvious. Sometimes the generator starts, runs for 12 minutes, and then shuts itself down because a sensor is reading a false overload condition. Sometimes it starts and runs rough, delivering inconsistent power that damages whatever's connected to it. Sometimes it simply refuses to start, cycling through error states with no feedback mechanism that a non-technician can interpret and repair. In Anchorage, you might find a service center. In Bethel and Nome, in Kotzebue, in Galena, you are looking at shipping the unit out, waiting weeks, and paying more in freight than the machine is worth. There is no YouTube tutorial for reprogramming a failed ECM with a screwdriver and a set of wrenches. There is no local parts store stocking replacement control modules for a generator you bought at Costco, a no-chip generator, a machine built around a carburetor, a mechanical governor, a point style, or simple electronic ignition without a management computer can be diagnosed with your eyes and your ears. A carburetor is gummed up, you can clean it. A fuel line is cracked, you can replace it. The ignition coil is weak, you can test it with a $12 spark tester and swap it for a $15 replacement that ships from any online parts house in 2 days. This is the difference between a tool and a liability. And in Alaska, the wrong answer costs you everything. Now, let's talk about the selection criteria that actually matter, because wattage is almost always the first thing people obsess over, and it is almost never the most important factor. Cold start reliability is everything. A generator that produces 8,000 watts but won't fire below 20 degrees is worth exactly 0 watts on the night you need it. Cold start performance comes down to 3 mechanical factors: compression ratio, carburetor design, and choke mechanism. Higher compression engines generate more heat during compression stroke, which aids ignition in cold air. A properly tuned carburetor with a manual choke gives you direct control over the fuel-air mixture during cold starts. You richen the mixture manually, coax the engine to life, and then lean it out as it warms up. Automatic chokes, especially electronically controlled ones, often fail to richen the mixture adequately in extreme cold. Manual choke is not old technology. In Alaska, manual choke is smart technology. Cold start reliability is everything. A generator that produces 8,000 watts but won't fire below 20 degrees is worth exactly 0 watts on the night you need it. Cold start performance comes down to 3 mechanical factors: compression ratio, carburetor design, and choke mechanism. Higher compression engines generate more heat during compression stroke, which aids ignition in cold air. A properly tuned carburetor with a manual choke gives you direct control over the fuel-air mixture during cold starts. You richen the mixture manually, coax the engine to life, and then lean it out as it warms up. Automatic chokes, especially electronically controlled ones, often fail to richen the mixture adequately in extreme cold. Manual choke is not old technology. In Alaska, manual choke is smart technology. Parts availability is a factor most people skip entirely when researching generators, and it is the factor that will determine whether your machine is a 10-year asset or a 3-year throwaway. Before you buy any generator, ask yourself, can I get a carburetor rebuild kit for this engine shipped to a P.O. box in rural Alaska within a week? Can I find replacement air filter, a fuel shutoff valve, an oil drain plug? The generators on this list use engines with enormous aftermarket parts ecosystems. This is deliberate. When you are 200 miles from the nearest hardware store, parts availability is a survival feature. Repairability by a non-mechanic matters more than you think. The average Alaskan is mechanically capable, but there is a difference between capable and professionally trained. A generator that requires specialized tools, proprietary diagnostic software, or factory-authorized service is useless in the field. Every generator on this list can be fully serviced with a basic socket set, a screwdriver, a wrench, and a can of carburetor cleaner. That is not a compromise. That is intentional design philosophy. Fuel efficiency during extended outages determines your real cost of ownership. A generator burning 1.5 gallons per hour at half load during a 5-day outage consumes 180 gallons of gasoline. At current Alaskan fuel prices, and if you are in a rural community, add another $1 to $2 per gallon on top of that. Fuel becomes a serious financial consideration. The generators on this list are not the most fuel-efficient machines on the market, but they are honest about their consumption. They run reliably at the consumption rates they advertise, and they do not have the chip-induced efficiency variations that cause ECM-controlled generators to burn significantly more fuel when they are struggling in cold conditions. Runtime per tank is related but distinct. A larger fuel tank is always an advantage in Alaska. Fewer refueling interruptions means more sleep, less exposure cold during nighttime refueling, and less risk of running dry and losing heat to a furnace that needs a restart. Look for generators with tanks that support at least 8 to 10 hours of runtime at 50% load. Noise level is last on the list, but not unimportant. In residential areas of Anchorage, Wasilla, or Soldotna, a generator running at 90 decibels at night will generate neighbor complaints and potentially code violations. In remote areas, excessive generator noise disrupts wildlife, can interfere with hunting and fishing operations, and is simply exhausting to live with during a multi-day outage. The generators on this list fall in a reasonable noise range, not silent, but not punishing. Here is where we get to the machines themselves. Before I name them, understand this. These recommendations come from a specific philosophy. No single generator is perfect for every Alaskan. A man running a remote cabin on the Yukon has different needs than a family in a subdivision outside Juneau. So for each generator, I'm going to match it to the Alaskan it was actually built for, even if the manufacturer doesn't know that is what they built. The first generator, the Champion 3500/4000 watt dual fuel. Recoil start, manual choke. This is the workhorse of Middle Alaska. Not the flashiest machine, not the most powerful. But for an in-town homeowner who needs to run a furnace, a refrigerator, a few lights, and a phone charger during a 3 to 5 day winter outage, this machine is almost unbeatable in its price range. Here is why Alaskans trust it. The engine is a 196 cubic centimeters single-cylinder four-stroke with no ECM. The choke is manual. The ignition is a simple transistorized system, not a management computer, just a basic electronic ignition that generates a reliable spark down to well below zero when the plug is clean and compression is good. The carburetor is a clone of a well-established Tillotson-style design, which means rebuild kits are cheap, widely available, and compatible with dozens of aftermarket suppliers. The dual-fuel capability is not gimmicky here. It is strategically useful. In a prolonged emergency, gasoline supplies can become constrained. Propane stores more easily, has a longer shelf life, and in many rural Alaskan communities is already on-site in large tanks for heating. The ability to switch between fuels without tools, without a conversion kit, without any modification. That is a practical advantage that shows up in actual emergencies. Cold start performance in this machine is genuinely good below zero when you follow proper winterization practices, which we will cover in a moment. Men who run this generator through interior Alaska winters report reliable starts down to -25 with fresh oil, a warm battery for electric start models, and a properly tuned carburetor. Who this generator is for: the homeowner in Wasilla, Palmer, Soldotna, or Ketchikan who needs a dependable backup for a standard residential load. Wants a machine he can service himself, and does not want to spend more than $600 on a generator he hopes he never has to use. What this generator is not. It is not a primary power source for a remote off-grid cabin. It is not a high-demand commercial unit. It is not designed for continuous 24-hour operation over weeks. Use it for what it is, a reliable residential backup, and it will serve for a decade. The second generator, the Honda EU 2200i inverter, but no ECM in the traditional sense. Now, before anyone closes this video, hear me out, because this recommendation requires an important distinction that most people get completely wrong. The Honda EU 2200i is an inverter generator, which means it uses electronics to produce clean, stable power output. There is a microprocessor involved in the inverter circuit, and that sounds like exactly what we said to avoid. But here's the critical difference. The inverter circuit in the Honda EU 2200i manages power output, not engine management. The engine itself, the GXR 124-stroke, runs on a straightforward mechanical fuel system with a manual choke and a simple transistor ignition. The engine has no ECM. It does not use sensor feedback to manage fuel mixture, ignition timing, or choke position. It is mechanically simple in the ways that matter most for cold weather reliability. The inverter electronics sit downstream of the engine. If they fail, which is rare, because Honda's inverter components are exceptionally well engineered, the engine itself is not affected. You lose clean power output, but you still have a running engine. And Honda's cold weather reputation is not marketing. It is 30 years of documented field performance in Scandinavia, Canada, and Alaska. The EU 2200i starts at -15 to -20 with proper oil, and this is important. You must use a low-viscosity synthetic oil rated for extreme cold, such as a 0W30 synthetic. Standard 10W. 30 becomes too thick to flow properly below 0 and dramatically increases start resistance. With the right oil, a clean plug, and fresh fuel treated with a quality fuel stabilizer, this machine fires reliably in conditions that kill its competitors. The other reason Alaskans trust the EU 2200i is its fuel efficiency. At 25% load, which is realistic for a basic residential backup scenario, it runs for up to 8 hours on 0.95 gallons of fuel. That is exceptional. During a 5-day outage running 8 hours per day, that is roughly 38 gallons versus 60-plus gallons for a conventional open-frame generator at similar load. In rural Alaska, where fuel costs $2 more per gallon than urban centers, that efficiency differential is not trivial. The noise profile is also dramatically better than any open-frame generator in its class. The EU 2200i runs at approximately 48 to 57 decibels, depending on load, quieter than a normal conversation at full load. In neighborhoods, this matters. In areas where noise ordinances apply, this matters. And in the wilderness, where you do not want your generator announcing your location to every bear within a mile, this absolutely matters. Who this generator is for? The Alaskan, who values long-term reliability above everything, has the budget for a premium machine, runs sensitive electronics like medical equipment or computers on backup power, and needs a generator that is quiet enough to run overnight without destroying his sleep or his neighbor's patience. What this generator is not. It is not a high-wattage workhorse. At 2200 running watts, it will not power a large electric resistance heater, a well pump and a furnace simultaneously, or a commercial operation. Know your load requirements before you buy. The third generator, the Generac GP8000E, open frame, carbureted, high output. This is a generator for the man who needs serious power and cannot afford to apologize for it. The remote cabin running a water pump, a chest freezer, a pellet stove with an electric auger, a bank of battery chargers, and a satellite internet router needs watts. Real watts. Consistent watts. Not inverter clean watts. Not efficiency optimized watts. Just raw, honest power output that does not flinch. The Generac GP8000, it delivers that. The engine is a 420 cubic centimeters OHVI, overhead valve, cast iron sleeve, built for extended run times. This is not a Chinese clone engine, and it is not a lightweight recreational engine. It is a purpose-built generator engine designed for continuous operation, and it runs on a straightforward carburetor system without an ECM managing combustion. The OHVI design runs cooler than traditional engine designs, which extends oil life and reduces wear during long-duration operation. Cold start performance on the GP8000E is adequate with proper preparation. And we have to be honest here, because adequate is not the same as exceptional. This engine benefits significantly from an engine block heater during extreme cold, a simple, cheap accessory that plugs into any outlet and keeps the engine block warm enough to start reliably at -30 or below. In Alaska, a block heater is not optional on a machine this size. It is as standard as oil. With a block heater, fresh synthetic oil, treated fuel, and a clean air filter, this machine starts reliably and runs continuously for extended periods. Men who operate remote lodges, hunting operations, and off-grid homesteads in interior Alaska use this generator, or machines in this class, as their primary power source for weeks at a stretch. The GP8000E has an 8-gallon tank. At 50% load, roughly 4,000 watts, runtime is approximately 12 hours. For a remote cabin running continuous operation, that means 2 fueling cycles per day, which is manageable. At lower loads, runtime extends considerably. Parts for this machine are widely available. Generac has an extensive dealer network, and the aftermarket parts ecosystem for OHVI engines is deep. Carburetor kits, fuel lines, air filters, spark plugs, voltage regulators, all of it ships readily to Alaska addresses, and most of it is available through multiple suppliers, which means price competition and reliable availability. Who this generator is for? The off-grid cabin operator, the remote homesteader, the commercial fishing operation that needs a primary power source rather than a backup. This is a machine for the man whose generator is not Plan B. It is Plan A, Plan B, and the only plan. What this generator is not. It is not quiet. It is not fuel efficient by inverter standards. It is not something you run in a residential neighborhood at 2 in the morning without consequences. It is a working machine, and it sounds like one. Now, before we talk about winterization, because every generator on this list, no matter how good, requires proper cold weather preparation, there is one more thing worth addressing directly. Why does the rest of the country not talk about this? Because the rest of the country does not need to. In Texas, in Florida, in Georgia, in California, generators fail and it is miserable. People lose refrigerators, lose air conditioning, lose lights. But the ambient temperature is 45 degrees. The generator that would not start gets brought inside, warms up, starts fine. The consequences are serious but recoverable. In Alaska, the consequences are not always recoverable. That is the difference in stakes that changes everything about how you evaluate backup power. And that is why the chip question, a question that barely registers in generator reviews written for a national audience, is the most important question a man in Alaska can ask. Winterization is not optional. It is maintenance. Every generator on this list should be winterized before each winter season and checked at the beginning of each month during winter operation. Use a full synthetic oil rated for the temperatures you operate in. In interior Alaska, 0W, 30 full synthetic is the minimum. Standard 10W. 30 thickens dramatically below zero and makes cold start significantly harder, increasing starter wear and pull cord effort. Use a quality fuel stabilizer in every tank if the generator sits for more than 2 weeks between uses. Gasoline degrades. Ethanol-blended gasoline, which is most of what you find in Alaska, absorbs moisture, which causes carburetor gumming, and phase separation at low temperatures. Treated fuel runs cleaner and stores longer. Install a block heater on any generator over 4,000 watts that you rely on in extreme cold. This is a $20 to $40 part that eliminates cold start hesitation and dramatically reduces engine wear during startup. Keep a generator-specific warm-up procedure posted in your garage. Start it. Let warm for 5 minutes at no load, then apply loads gradually. Never slam a cold engine with full load on startup. Drain the carburetor float bowl if the generator will sit and use for more than 3 weeks. This single step prevents more service calls than any other maintenance practice. Store your generator in the warmest available space. An insulated garage is ideal. An unheated shed at -40 is where generators go to develop problems. 3 generators. 1 philosophy. No chips where they do not belong. No compromises where it matters. No generic advice recycled from a reviewer who has never stood in an Alaskan garage at midnight wondering whether his family is going to be warm by morning. The Champion 3500 dual fuel for the in-town homeowner who wants dependable backup at an honest price. The Honda EU 2200i for the man who demands premium reliability, fuel efficiency, and clean power for sensitive equipment. The Generac GP8000E for the off-grid operator who needs sustained high-output power and is willing to maintain the machine that keeps his operation alive. These are not the only generators that work in Alaska, but they are 3 that have earned trust the hard way. Through actual winters, actual outages, actual temperatures that no specification sheet fully prepares you for. Buy right once. Maintain consistently. And when the power goes out at midnight in February and the temperature outside is falling and everyone inside is counting on you, you will start on the first pull. That is what this is all about.